All right, on page 2 of your 3-4 notes, I think a lot of you will like this. This is more problem-solving, algebra-based than the proofs. We are going to use what we just talked about on the first page. So a lot of isosceles triangles here. So in number 1, 110 would be considered your vertex angle. And you have these little congruent marks here. So you should be able to recognize that x and y are exactly the same size. If they're exactly the same size, and this is a triangle, you should be able to do 180 minus 110. So you've got 70 degrees left between the two triangles, and they're the same. So half of that, each one is 35 degrees. So that's for x as well as y, because they are congruent. All right, let's see, our number 2. A couple things that are super easy to pick out. This must also be 10 degrees, right? Because you've got these two little congruent marks. Angle y down here must also be a right angle. And let's see, if your vertex angle is a total of 20 degrees, again, you've got an equilateral triangle, or sorry, not an equilateral, isosceles triangle here, because you've got two sides are the same. So on the last page we talked about if two sides are the same, two angles, your base angles, must also be the same. So these two angles are exactly the same. And just like number 1, if we subtract away the vertex angle, that leaves us with 160 degrees. And these two angles add up to 160, and they're the same. So they must be 80 degrees each. So x is 80 degrees. We have y is 90, and that's it. Number 3 is a bit more involved, even though it's only asking for one thing. You need to recognize that if you've got 4 sides in one right angle, this here is a square, right? So squares, all of the angles are right angles. So we've got 90 degrees right there. These two triangles coming off the right side and the bottom are equilateral triangles. And if you've got equilateral triangles, they're also equiangular. So, well, not 360, thinking ahead, 180 divided by 3. Each angle is 60 degrees. So this here is 60, and so is that. Now what we're going to have to do in this particular problem, we're going to have to consider the fact that angle T is outside of there. So we're going to consider this circle here. So that's a new idea. You might have to do that on your homework or a test or quiz. So think about all the way around there. So what we have so far, you've got 90, 60, and 60. So you're going to take those away from the full circle of 360. So 360 minus 90 minus 60 minus 60. And that's going to leave you with 150 degrees for angle T. All right, number 4. Number 4, you've got an isosceles triangle. If you want to, you can turn your page like that. Some people like the base to be actually on the bottom. This is the vertex angle, remember? The base is the side that's not the same, and now that I have it turned, the left and the right side here, those are your legs. So you know that this up here, this is 90 degrees total, right? So angle S, I think they're referring to just part of it. So that's going to be 45 degrees. We've got that. Also, we're assuming that since these two sides are the same, these two parts of the angles would have to be the same. That's why we knew it was half of 90. And then from here, you've got 90 here. So what's left? 180 minus 90. You've got 90 degrees left between your base angles here. So divide that by 2. Each of your base angles are 45 degrees. So R is 45. For number 5, let's start out with X probably. You've got a linear pair here. So 180 minus 125 leaves you with 55 degrees for angle X. You should note that this is an isosceles triangle, so if the two sides are the same, then the two angles are going to be the same, your base angles. So this is also 55, and then if you just use this idea here, bring it over here, Z is also going to have to be 125 because they're a linear pair. And if you've got two 55s, you've got a total of 110 degrees, and 180 minus the 110 leaves you with 70 degrees for angle Y. Number 6, it tells us it's a regular polygon. WXYZV. So that's WXYZV. That, it is a regular polygon, but more specifically, it's a regular pentagon. So we've got that to think about. Let's start here with C, actually. With C, C is a part of an equilateral triangle, so therefore C is 60 degrees. This angle A, hopefully this is reminding you of number 3, where we're going to have to think about the full circle here. So the full circle is going to be 360 degrees. And then if we add in some things here, this angle too will be 60 degrees. For here, where the Z is, this angle here, they didn't ask for it, but we're going to have to do a little math here. This is a pentagon, so there's 5 sides. So to figure out each interior angle, we're going to have to do n minus 2, n being the number of sides, 5, times 180, and then divide by 5 to give you each one. And that's going to give us 180 times 3. You could draw 3 triangles in a pentagon, is 540. 540 divided by 5. Each interior angle, all of angle X, all of angle Y, all of this where Z is, each of those are 108 degrees. So that kind of answers our angle B here. Angle B, that's 108 degrees. And then this down here will be another 60. So once again, just like in number 3, it's pretty similar, only your angle here is 108, not 90. So you've got an extra 18 degrees here. So your answer for A here compared to T will be 18 degrees less. Or you could just think 360 degrees in this whole circle. And again, subtract what we know, 108, 60, and 60. And that leaves us with A is 132 degrees. Number 7, 7's easy peasy. It tells you, there's these little tick marks here, this is an isosceles triangle. They match, so X and 2X minus 6 are equal. Usually we get rid of the smaller one, but that would leave you with nothing. So I'm going to do negative 1x equals negative 6. So x is positive 6. That was nice. Number 8, where do we want to go there? Okay, so they only give you 30 degrees, so I guess we better start here. If this is 30, 180 minus 30, that's 150 degrees between these two vertex angles, and they're identical. So each of them must be 75 degrees if you divide by 2. And then that just kind of opens up a lot of things. This must be 75 and 75 because they have the same congruent marks. This must be 75 and 75. And then, so if you've got the same 2 base angles, your vertex angles must also be identical. So if this is 30, so is this and that. So they're all 30 or 75. All right, and then number 9 here, let's see what we've got. They labeled this 60 degrees, so we can kind of try to run with that. This is referring back to if you've got a perpendicular bisector, if your line's perpendicular, then it's bisecting it. So this is also 60 degrees here. So you've got 60 and 60. And then again, these are equilateral triangles. So 60 here, 60 here. So you've got 1, 2, 3, 4 60s. 4 times 60, that's 240. And again, we're going to think about the whole circle. If we've got 240 degrees accounted for, we've got 120 degrees left to be angle Z. Okay, this one down here, I think most people will find it pretty okay. These are just a ton of isosceles triangles inside of each other. So AF, let's try to color code this if we can. AF is this whole side. So I think we all know that that's going to match with AD. And we know that because these base angles are the same. So that is true because angle F is congruent to angle D. That's the whole sides. All right, number 2, CA. CA is here to here. So that is going to match with this side, GA. And again, we know that these are the same, congruent, because their base angles are congruent. Angle C and angle G match up. KI, here it is. KI must be congruent to KJ, because again, their vertex angles, the base angles, that's what they're called, base angles are congruent. So JK, angle J is congruent to angle I. Number 4, EC. EC is here. So a congruent part would be here, CD. And their base angles, oh, let's see. I suppose we should be using more letters here. Probably, Okay, let's go here and then go back. Angle CED is congruent to angle, that one we can call angle D. If we go back here to number 3, you can't just really call that J because you've got 2 parts to J, so we should probably call it KJI. And angle I, we want this side of it, so that's going to be KIJ. And then same thing for number 2. Let's see, we wanted CA and GA. So we can say angle JGH is congruent to BCH. There we go. All right, moving on. Running out of colors. Number 5 is JA. So that's this part here. And that's going to match with this part here, which is AB. Because their base angles are congruent, AJB is congruent to ABJ. Move that up for you. HB is this little guy here. So he's congruent to the other side, BC, because their base angles are angle BHC and then BCH. And one more, angle D is this over here. That must be congruent to angle F. The reason, I don't know, maybe I've wrote too much and I've covered it up. I'm not sure if we have a reason besides AL is perpendicular. So you've got a perpendicular bisector here. So that's going to make it isosceles. So you could say AL is perpendicular. And then you have that these two are congruent, so the rest would have to be as well.